Okay, so I'm talking about integrated rate laws here, and we know that if we have a reaction with one reactant, if that reaction is first order with respect to A, the reactant, if we plot log of A versus time, we will get a straight line with intercept equal to log of the original concentration of A, the concentration at time equals 0, and slope equals minus K. If we have a reaction that is second order with respect to A, if we plot 1 on the concentration of A versus time, we'll get a straight line, but the intercept will be 1 on the original concentration, and the slope will be positive now, and that will be equal to our rate constant. For some rare cases, we might get a reaction that is zero order with respect to the concentration of our reactant A. And for these reactions, if we plot A, the concentration of A versus time, we'll get a straight line. It'll have intercept equal to our original concentration at time equals 0, and the slope will be negative, and it will be equal to minus K. So a typical problem might look like this. We have a reaction with one reactant, we have some time data, and we have some concentration data. And the question asks, is the reaction zero order, first order, or second order? It then asks, what is the rate constant? So what we're going to need to do is plot the concentration versus time. If that is linear, then our reaction is zero order. Then we will plot log of the concentration versus time, and if that gives a linear plot with a negative slope, then the reaction is first order. And then finally, we will plot 1 on the concentration versus time, and if that is linear with a positive slope, then we know that our reaction is second order. Once we've identified whether our reaction is zero first or second order, what we'll do then is we'll calculate the slope of our linear plot and we'll get K. So at a minimum, what it's looking like we're going to have to do is 3 graphs and 1 slope calculation. So there is a quicker way using your calculator, and I'll show you how to do that now. So I'm just going to pop up my calculator and turn it on. That really helps. And what I'm going to do is I'm going to create a stat table. So I go stat, and I'm going to edit a new table, so option 1. And in the first list, list 1, I'm just going to put my time data. 0, 50, 100, 200, 300, and 400. And then in list 2, I'm going to put my concentration data. 0.1, 0.0707, 0.05, 0.025, 0.0125, and 0.00625. Okay, now when it comes to list 3, what I'm going to do is I'm actually not going to enter in any values here. I'm going to enter in a formula. And I want to put in, I want the log of my concentrations in list 3. So I'm just going to hit the natural logarithm button. And then second function of will give me list 2, which is my concentration data there. Close the parentheses and enter, and it's like magic, it does all of them. For list 4, I'm going to go up into the heading again, and now I want 1 over the concentration. So I want 1 divide by the values that are in list 2. And then enter, and it auto-populates list 4. So now I want to check out whether list 1 against list 2 is linear, time against the log of the concentration is linear, or time against 1 on the concentration is linear. So what I have to do now is I go into my stat menu, and I'm going to get it to do some calculations this time. And what I want it to calculate is what's called the linear regression. So I go over 1 to calculate, and it's option 4. So 4, linear regression. And so list 1 is my time, and list 2 was my concentration. So I can check whether it's zero order. I go down to calculate and hit enter. And away it goes. And the number that I'm looking at here is the R squared. And if that number is very near 1, then that tells me I have a linear relationship, and I don't. So I've automatically identified that this is not 0 order. So now I go in and check my next possibility. I go Stat, Calc, Option 4. I want my x's to be time again, which was list 1, but now I want my y's to be the log of the concentration, and that was list 3. So second function, 3, and then I go down and calculate, boom, and there it is, and my r squared is very close to 1, so I've identified that it's linear, and it calculates the slope, that identified that this is linear, so therefore it is first order, and it calculates the slope for me, which was minus 0.00693. For this plot, the slope is equal to negative of k, so I've got my k value there. It is 0.00693. So I'm done. I figured out that it was first order, and that k was equal to 0.00693. So that's it. All I have to think about now is what are the units for a first order rate constant, and that is going to be time to the minus 1, so it'll be seconds to the minus 1. So I'm done. I didn't plot anything, I didn't calculate any slopes, I got the calculator to do everything for me. Now let's just go back and check that it's really not second order. So I go into my calculator again, and what I'm going to do, Stat, Calc, 4, list 1 is always going to be what I'm going to have in the X list, that's my time. But now I want to make this list 4, which will be my values of 1 on the concentration. So second function, number 4, and then go down to calculate, hit enter, and this r squared, sure enough, it's not 1. So we identified it wasn't 0 order, it wasn't second order, it definitely was first order, and there's the k value, and it took all of about 5 minutes. Okay, that's how you do it. See ya. Bye.